Existing techniques supporting parallel coordinate axis reordering do not offer any details on how a final axis reordering was generated using these algorithms. Also, almost all of them work directly on a whole axis to calculate different metrics, and no local information is considered. Further, some of the most versatile and accurate parallel coordinate reordering techniques are usually very slow for any particular application. To alleviate these issues, in this work we present PC-Expo, a metric-based interactive axis reordering method for parallel coordinate displays. PC-Expo offers several advantages like fast implementation with localization support for detecting patterns on low-level smaller regions in the data using a human-in-the-loop interface. With PC-Expo, users can use their domain knowledge to reorder the axis and add explainability to why a particular axis ordering was obtained for a given set of criteria. This is the demo of PC-Expo, which has several views, which combine supports efficient PCP axis reordering and accurate data storytelling experience to the users. This is the main view where users can visualize and evaluate the final axis reordering. On the right is the property view supporting all the different data analysis tasks which can be performed with PC-Expo. Underneath these properties is the localization control window where the users can control the size of the regions where these properties are detected locally in the dataset. And finally, at the bottom of is the data feature selection tool, which is used to filter the variables users want to visualize in the parallel coordinates. For human-in-the-loop and explainable axis reordering, PC-Expo has local visualization views combining this heat map and the local parallel coordinate view along with the scatter plot. The heat map shows the final scores obtained for every axis pair in the data using the properties chosen by the user. And user can select any of these axes from the heat map, which are updated on this local view, where we can see all these properties and how they were detected on a pair of axes along with these scatter plots. The scatter plot shows the two-dimensional view of those axis pairs, giving more information to the user on different local clusters in the dataset that exists. Let's do some sample axis reordering experiments with PC-Expo. In this experiment, we choose to detect fan, split up, and high variance patterns in the dataset. So we can select a weighted optimization function using the sliders, giving weights to these properties. The donut chart here summarizes how much weight is given to each of the property in the final score calculation. Clicking on recommendation generates scores for every axis pair in the data in real time. As we can see, this heat map is updated with the final scores based on where some of our selected properties were detected in the dataset. Now we can separately visualize how these scores were calculated by clicking on this matrix cell, which updates this local view, and we can explore different regions in the data for each of the properties as they were detected in the system. For example, a high region was detected for this axis pair in this region, and we can drag on the corresponding points which get highlighted on the scatter plot. To quickly generate these axis orderings based on the properties, we can click on Global Optimize, which reorders this parallel coordinate based on these calculated weighted sum values. The Show Properties button on the top shows where exactly in the local regions these properties were detected and their corresponding values. So this is one way to add explainability to the process of automated axis reordering. For another use case of PC-Expo, let's do multi-property axis reordering. In this process, we use PC-Expo to reorder parallel coordinates based on the most prominent properties shown by any axis pair in the data. So for this example, let's start with first optimizing for fan-shaped structures in the dataset. As verified, the highest fan value is shown by this axis pair, which we can visualize using the local view. So to reorder the axis, we can double-click on the cell in the heat map that starts the axis reordering process based on the fan property. The next axis, let's choose the split up as the optimizing property. As you can see, it's not very clear which is the highest value cell, so we can visualize it in the local view to make the decision. Similarly, we can choose other properties to find the best property for current ordering of the axis pair and do this for every other pair in the heat map to find the most prominent reordering based on the properties chosen by the user. This is another way of data storytelling with parallel coordinates, where the properties which are most significant are shown on the axis. So as shown in these examples, PC-Expo supports human-in-the-loop, localized, fully explainable, and fast parallel coordinate axis reordering, with all the properties being available in one single interface. Please check out the paper for evaluation results and more details on PC-Expo.